So there are lots of issues with pathway modelling, and I've tried to illustrate some of this. And what we're about to attempt to learn today, obviously in a very small session, is that actually you can do it. It's not simple, and perhaps I've already illustrated there's many different attempts to try and do this, and some of them are more successful than others, let's say. Now, one of the issues with this is that we don't know what all proteins do. There's still quite a lot of proteins or genes within the genome which don't have a name. We don't know where they fit into anything. So actually, in terms of detailed knowledge about proteins, then it's vague. There's also a real problem is that when you start describing a pathway, you'll read a bit of information around that pathway, but actually, and you'll claim the things that you read to be part of your pathway. But it can be quite equally case that they're part of another pathway. So in KEGG, you'll find certain enzymes which are listed in 15 different pathways. Okay, so which pathway? So, a pathway to a certain degree is a human construct. What we're actually thinking about is this huge interaction network between proteins, biochemicals, genes, and DNA. And what we are then going to do is saying, I'm going to draw a pathway of this particular chunk of it. And in doing that, you say, actually, this is part of my pathway. And it's amazing how many signaling pathways you start drawing them out, and you end up with the NF-kappa B system, okay, as part of that. Because a lot of things actually use common systems. They're not nicely separated out as we'd like to think of them to be. This I think I mentioned this issue over naming components, that if people aren't very fastidious about how they actually name components, then you're left with uncertainty about what it is that's being represented. There's often lack of information, so these things are often just pictures. The people draw these things, and there's no information that supports where they got the information from and how they actually assembled this diagram. It's, well, I think a diagram only. You get them. Now, I'm going to talk a little bit about standard formats in a moment. There are a number of standard formats for this, so people have put forward ideas about how information should be stored, how this information should be represented graphically. That should be biopacks, not piopacks. And then there is this issue with, once you start building these diagrams on any scale, you're kind of trying to lay them out so you retain that human readability. And the bigger the diagram becomes, the more difficult it is to maintain that link between what you're representing and your ability to see it. And of course, a lot of there's a lot of, I suppose, lack of knowledge about what cell you're representing here, what species is that, and these things kind of often get lost in the diagrams. So there's basically lots of different ideas about how to model a pathway. And views of what components constitute a pathway is a subjective thing. So that's just a matter of fact. We can't get around with that. That's just the case as it is. So we needed a standard approach. So this is 4 different ways you could represent apoptosis. And as you can see, again, they're all very different graphically. The way that they name components is similar. And if you wanted to summarize that information, it's non-trivial to do that, okay, as a single diagram.